In Unity, there are two main methods of making player movement. The first method is using the character controller component, and the second method is using the rigid body component. Now, why would people use one over the other? It is because the rigid body is physics-based and the character controller isn't. If your game requires for the player to interact a lot with the environment, then a rigid body controller would be appropriate since rigid bodies are within Unity's physics loop and can properly interact with other physics-based objects. If your game doesn't require for the player to interact with the environment as much, for example, an FPS game, then a character controller would be suitable as it is more simple and optimized for a static environment. Now that we have a basic understanding between the two, we can now get into coding them, so let's do it. Okay, so here I have a Unity scene with a rigid body player object. It contains a rigid body that has all the rotation axes frozen. So what that means is the rigid body will not influence the rotation of our game object. And there's also a script attached to the player object, which is the rigid body movement script, which is the main premise of this section. And there is also a bunch of these cubes. This is mainly for fun because cube. They also have a rigid body, so we can watch physics happen and show how these two elements, or all these elements, interact with each other, especially the rigid body player object. So now we can go into our rigid body movement script and we can start working on this. So the first thing we want to have done is a reference to our player's rigid body. This is so we can, influence the velocity and all that, make it actually move. And now we're going to have a reference to our player camera transform. This is so we can rotate the player camera with our mouse. Now beneath, we're going to put a space to make it look clean, and we're going to create some more properties for general speeds, like the movement speed, the player sensitivity, and the player's jump force. Sure. So we're going to create a float for the speed, float for the sensitivity. The sensitivity is for the mouse, like when we move our camera around, and a private float for the jump force. There. Now at the very top, we're going to create two private variables. The first private variable is going to be a vector3, and it is going to be a movement player movement input. And we're also going to have a vector2, and this is going to be our player mouse input. So we don't need the start function. Before we do anything in our update function, we're going to create two separate functions. The first one is going to be for moving the player, and the second function is going to be for moving the player camera. So in our update method, we're going to set up our movement input. So player movement input equals new vector3, and here we're going to do input.getAxis horizontal 0, because we're not going to influence the y, but we will influence the z-axis. GetAxis vertical. So what this line of code does is that it records the input for the main movement keys. So like if we're tapping into the ID, the string ID of horizontal, we are looking for the A and D keys, so basically left and right. If we press A, it will return as -1, and if we press D, it's going to return as +1. And for the vertical, it's going to be looking for W and S. If we press W, it's +1. If we press S, it is -1. And there is another function alias of this. It's like getAxisRaw. So the main difference between getAxis and getAxisRaw is that getAxis has smoothing on it. You can see it on the little tooltip here. Well, you can't really, never mind. But when you type in getAxisRaw, you're going to see no smoothing filter applied. And that is the difference between getAxis and getAxisRaw. So now we're going to set up the player's mouse input. Player mouse input equals a new vector2. And we're going to use the same function, input.getAxis, but this time it is going to be mouse x. So that will be moving our mouse left to right, and input.getAxis and the mouse y. This is for getting, make sure it's proper, a mouse up and down, left and right, all that. Now we're going to call our move player function and our move player camera function. So now we generally have everything set up for all the movement. So we're going to first work with moving the player itself. So what we're going to do is we're going to create another vector 3, and we're going to call this our move vector. And it's going to be in transform direction, and our direction is going to be our player movement input. And we're going to multiply this by the speed. And once we have our move vector, we're going to do player body dot velocity equals a new vector 3 of the move vector dot x player body dot velocity dot y and move vector dot z. So the reason why we are not multiplying this by the speed is because of the player body velocity y. The reason why we're not doing it because of this is because when the player is falling down, right, the y velocity of the rigid body is going to be different. And if we multiply that by your speed, we're going to be going down fast. Like, we're going to teleport to the floor, and we don't want that to happen. So we're going to multiply our player input by the speed, since we only want to have the speed influence our movement forward, back, left, and right, not up and down, because that will cause a lot of problems down the line. So this line is generally done, but we're also going to implement jumping. So what we're going to do is we're going to create an if block, and it's going to be if input dot get key down, and it's going to be key code dot space, the regular jumping key. We're going to do player body dot add force, and the force is just going to be vector 3 dot up, multiply that by our jump force, and it's going to be in force mode dot impulse. There. So this is just for jumping. Impulse is like an explosion, right? It's like instantaneous force. That's why we're using impulse. So now if we go back into Unity and we assign all of our variables, the player camera isn't being used yet because we haven't really done the player rotate thing yet. So in the speed, we're gonna have 5, sensitivity could be 3 if that's for later, and the jump force will be 10 there. So now if we hit play, if we press W, A, S, and D, or the arrow keys, the player will now be moving, and you can see how the rigid body controller easily interacts with all the cubes around it. But the last thing that we need to put on before this is a complete character or player controller is the player camera movement. So what we're going to do now is at the top here, we're going to create a private float and call this XROT, which is like just X rotation. And in our move player camera function, we're going to subtract that by our player mouse input dot y, multiply that by this sensitivity. The reason why, gotta fix that. Okay, so the reason why we're saying X rotation, even though we're referencing to the Y axis, is because when we go back into the inspector, or not the inspector, but the scene, right? When we rotate, the X axis is what makes things look up and down. So that is why we are saying X rot and not Y rotation. The Y rotation is what makes the player turn left and right. So now that we have this set up, we're going to do player camera dot transform dot local rotation equals quaternion dot Euler, and in here we're going to do the X rotation 0, 0. And now before that we're going to do transform dot rotate, and we're going to do 0 and then the player mouse input dot y, or dot x, sorry, multiply that by the sensitivity and 0. There. And that is the rigid body movement. So now if we go back in, let me set the sensitivity to 3. See that we can look around freely and we can interact with all the cubes. And if we press space, our jump function works. And you can also jump in the air. And if you don't want this behavior, I'll go over that real quick, but this is what the rigid body controller can do. We can run around, we can mess around with all these cubes, these physics-based objects. And yeah, to prevent jumping in midair, what we can do is have a volume check every time we want to press space, right? So put it at the feet, right? And then call this game object the feet. And we're going to create a separate layer for the floor. And we're just going to call this the floor layer. We're going to mark this as the floor layer. Sorry. So like any floors or like any platform you want the player to be able to jump off, mark it with the floor layer. And in our script, when we press space, we're going to do if physics.check sphere. And the position, we're going to create a reference to that. Serialized field, private, transform, feet transform. The feet transform dot position. And the radius can be whatever you want. I'm going to set it to 0.1. And the layer mask, we're going to create a reference to that as well. Private layer mask, the floor mask. And we're going to set that to the floor mask. And we're going to put our jumping line within this if statement. And now if we go back into Unity and assign the feet to here and put the floor layer in the mask and we hit play, you can no longer jump in midair. Oh, let me change the sensitivity back. Here, I am spamming my space bar and I'm not jumping midair. And this is the rigid body movement. Now we can get on to the character controller movement. Alright, so in this scene right now I have the physics cubes and the player object. And behind me is a staircase to show one feature of the character controller that is fairly useful. So now let's go into our player object. Should have a character controller component and a character controller script, or the script that you're going to use. So now if we edit this, we can get to work on it. So first, we are going to need a reference to our character controller. Private character controller, we can call this the controller. And we'll also need reference to our player camera and the usual down here. So, you know, the speed variable, its jump force, sensitivity, and we're going to have an extra parameter, and it's going to be our gravity. Because the character controller is not physics-based, we're going to have to program our own physics into our character controller. But it's going to be very basic. We're not going to get too in-depth when it comes to, you know, like we're not going to worry about adding forces and doing all that fancy physics stuff. We're just going to stick with regular gravity. Just push us down. So set the default for this. Normally gravity is negative 9.81 meters per second squared. That's the force. And now we're going to create two private voids. Move player and so the move camera function, it is exactly the same as the rigid body movement, like camera movement. So we can just copy this over. We can really just do that. Copy that over. You know, the player mouse input. Alright, so the player camera movement is set up because this is fairly universal amongst moving the player camera, like rotating the camera based on the mouse. It is the same all the way throughout, unless you want to have something fancy like smooth camera rotation, like you would want to lerp it or something like that. But we're not going to really mess around with that in this video. This is just to show you the basics and give you an understanding of how to program character controller movement and rigid body movement. So continuing on. Right now, we're going to create our player movement variable, player movement input, and we're going to update this. Input.get axis horizontal 0. Actually, no, not 0. Actually, yes. Input.get axis, not raw, vertical. And now that all of our vectors are set up, we can call our move functions beneath camera. Now this is where the main difference is. This is where it gets different, right, in this move player function. So we're going to need another variable, and that will be our velocity. So private vector3 of velocity. And in our move player function, we are going to take our controller and we're going to do .move, and we're going to put our velocity in here. And above it, we're going to do controller.move, and then in here, what we're going to put is our move vector. So to get our move vector, once again, you just do vector3 and your variable name, and it is transform.transform direction, and our direction will be our player movement input. And we can put this in here, and this time we can multiply our speed inside of our move function. So move vector, multiply that by our speed, and multiply it by time.delta time, so you don't go at the speed of sound, or the speed of light actually. So that is all set up. Now for our velocity, how do we set up our velocity? So we want to apply gravity, right? And there's an equation for that, which is basically just y equals gravity, or minus equals gravity multiplied by -2 multiplied by time.delta time. And then we multiply it by delta time in here again because it's time.delta time. It's just time squared. So to apply this, we can simply subtract the y on our velocity with this equation, but we do not want to subtract it every time we move, all right? That's not good. We can't do that because you don't build up velocity for falling down when you're standing in place on the ground. Like, it doesn't work that way. So we're gonna have to check if the player is on the ground. And this time, instead of using a separate object and doing a physics.checkSphere function, the character controller has a built-in boolean for that, and it's called isGrounded. So if we do if controller.isGrounded right there, then we're gonna set our velocity to 0. Like our velocity.y to -1, not 0, sorry. So velocity.y equals -1. There. And if we are not grounded, then we're going to apply this equation. Velocity.y minus equals our gravity. Multiply that by -2 multiplied by time.delta time. If we're going to multiply by -2, is just get rid of that sign there, the negative sign there. And we move with our velocity, multiply by time.delta time here because it is time squared. So now this is mainly what we have to do for our movement. So if we go back into Unity and we assign all of our variables, set our speed to 4, 3, and 9.81. Oh yeah, jump force, sorry. Forgot to implement jumping. So for jumping, that's also very, very simple. All we have to do before, or actually after, no, yeah, before, it's before. Before we move, like before we apply all of our velocity and stuff, we do if input.getKeyDown keycode.space, and we want to be grounded, so we're going to put this in our nested if statement, and we're going to set our velocity.y to our jump force. There. Now it is completely set up. Alright, set our jump force to 10. Now if we play, okay, I think it is supposed to be negative 9.81. I forgot I'm subtracting, my bad. Okay, now you notice that we can jump around, and these cubes here, they have rigid bodies, and look what happens if I run into them with the character controller. Nothing happens. That is because the character controller is not within the physics loop, and it cannot interact with physics-based objects. But there's one thing that I like about the character controller. There's automatic stepping. It automatically moves the player up, and if I come back down and I scale this up a bit, if I just move this up, and you can see that it snaps. Hang on. There's a parameter on the character controller that you can increase the step offset. If I just increase that so I can actually get up here, there, it snaps me going up the stairs. And this is very useful. And that is it. That is the character movement for rigid bodies and character controllers. If you learned something, like, subscribe, you know, the usual. And I'll see you in the next video or tutorial.